Okay, so let's start. I hope everyone is having a great day. Let me introduce myself first. I am Anna, mobile development expert, passionate about quality software from Ukraine. I am Google developer expert in Dart and Flutter, and I recently became a Women Tech Makers ambassador. I have 8 years of experience in cross-platform mobile development, and I have been dealing with Flutter for work and leisure for over 3 years now. I currently work as a senior staff mobile engineer in a fintech company called Tide. And I'm here today to talk about Flutter. According to the official website, Flutter is an open source framework by Google for building beautiful, natively compiled, multi-platform applications from a single code base. By the way, from time to time, you'll see some useful links just in case you decide to dive deeper into the topic. Flutter was started a few years ago now with the idea to change app development. It combines the iterative development model of the web with hardware-accelerated graphics rendering and pixel-level control that were previously a privilege of games. Over the last 4 years, since first Flutter releases, the Flutter team has gradually built on these foundations, adding new framework capabilities and new UI components, deeper integration with the underlying platform, a rich library of packages, and many more performance and tooling improvements, all of which increases development, productivity, and robustness. Flutter was built to revolutionize UI development. It is an open source toolkit supported by Google for building beautiful and fast user experiences for any platform. It is fast with hardware-accelerated graphics, regardless of which platform you're deploying to. And with pixel-level control over your UI, Flutter gives you the ability to create beautiful, tailored, highly branded experiences. It is built to decrease the traditional edit, compile, deploy, debug cycle, and instead offers productive support for iterative live coding, where developers can just hot reload changes without restarting the app. And finally, Flutter lets you write UI with a single shared code base, whether you're targeting a web, mobile, or desktop, so it's portable. So with Flutters, teams and companies no longer have to ask what platforms they are targeting. Instead, they can focus their effort and energy on their idea and their creativity. If you're a company shipping a product for multiple platforms, you do not have to run at the speed of the slowest team anymore. Instead, all of your engineering resources can be focused in building amazing experiences on all platforms you are targeting. With Flutter, you can target 6 distinct platforms out of the box: iOS and Android, mobile and desktop web browsers, Windows, macOS, and Linux. To understand how this portability became possible, I'd like to talk about each of these platforms: desktop, web, and mobile. For starters, let's take a look at Flutter architecture for Windows, stable support for which was announced in the last release. On top, you see the Flutter framework. It is the layer developers typically interact with. It is a reactive UI framework, providing a rich set of widgets, layouts, and foundational libraries. Below it, you see the Flutter engine. It is the core which supports lowest level primitives necessary for all Flutter applications, including input, graphics, and text rendering subsystems. The engine is platform agnostic, presenting a stable application binary interface that provides a platform embedder with a way to set up and use Flutter. And finally, at the bottom, there is a platform embedder, which is the native operating system application that acts as a glue between Flutter and the host operating system. If you Google Flutter architecture, you will see a lot of images similar to this one. Framework and engine layers are always the same, and it is the embedder that changes from platform to platform. So Windows and Flutter communicate through an embedding layer that hosts the Flutter engine and is responsible for translating and dispatching Windows messages. Flutter coordinates with Windows to paint your UI on the screen, handles events like window resizing and DPI changes, and works with existing Windows modalities for internationalization, such as input method editors. Just as with the support for Android and iOS, the Windows implementation of Flutter combines a Dart framework and C++ engine. At Google I/O last month, a new Flutter major release was announced, Flutter 3, which brings a stable support for macOS, which means you can now build beautiful custom experiences. And if required, you can also build that fully embodying macOS system look and feel with a special macOS UI package. And now you can sign your executables so that users don't get warnings about untrusted publishers. A few words about Apple Silicon. It is a new processor architecture installed in Apple's latest hardware. Flutter has just worked on Apple Silicon since day one through Rosetta, which is a software that enables a Mac with Apple Silicon to use apps built for Mac with Intel processor. But now a native support has been announced. When using those machines as your development environment, you'll no longer need to rely on Rosetta when analyzing or compiling code for Flutter apps. And it was also announced that Flutter supports building both x64 and ARM64 binaries. Previously, Flutter could build apps that run on Apple Silicon only through Rosetta translation. Now, however, the SDK delivers code compiled natively for ARM64. So your users can get the speed and stability expected from well-made applications. With Flutter 3, also stable support for Linux was announced. Canonical are the organization behind one of the most popular distributions of Linux, Ubuntu. So Canonical and Google are collaborating to offer the best highly integrated options for development. Adding a platform support requires more than just rendering pixels. It includes new inputs and interaction models, compilation and build support, accessibility and internationalization, and platform-specific integrations. So there is now a suite of packages that add tailored UI and integration with system services, as well as comprehensive theme and UI components set for Yaru, which is the Ubuntu look and feel. Okay, moving on to the web. Stable support of Flutter for web was announced back in 2021 with Flutter 2 major release. While the general architectural concept applies to all platforms that Flutter supports, there are some unique characteristics of Flutter's web support that are worthy of comment. Dart is a programming language used in Flutter development. So Dart has been compiling to JavaScript for as long as the language has existed, with a toolchain optimized for both development and production purposes. Because the Flutter framework is written in Dart, compiling it to JavaScript was relatively straightforward. However, the Flutter engine written in C++ is designed to interface with the underlying operating system rather than a web browser. A different approach is therefore required. On the web, Flutter provides a re-implementation of the engine on top of the standard browser APIs. This is the web version of the architectural layer diagram. Perhaps the most notable difference compared to other platforms that we saw previously is that there is no need for Flutter to provide a Dart runtime. Instead, the Flutter framework, along with any code you write, is compiled to JavaScript. Okay, Android and iOS mobile platforms were the first ones targeted and supported by Flutter. I took this screenshot from the official website, and I think it perfectly describes the advantages of developing mobile applications with Flutter. It allows you to reach your users on all platforms, including mobile devices, from day one. It also allows you to have one team of professionals with shared expertise in one language, Dart, and in one framework, Flutter, as opposed to having two teams of native developers. And it allows releasing to both platforms simultaneously and reach feature parity for the best experience for all users. Even though mobile platforms support is the oldest in the framework, the latest Flutter 3 release also had some new features like support for foldables devices and Material 3 UI components. The latest Flutter release largely completes the work for Material Design 3, allowing developers to take advantage of an adaptable cross-platform design system that offers dynamic color schemes and updated visual components. Okay, I want to show you something cool. This year at Google I/O, they presented a breathtaking case study, a great example of how Flutter enables beautiful experiences. Meet the Superlist desktop application. Superlist provides supercharged collaboration through an application that combines lists, tasks, and free-form content into a to-do list and personal planning. The Superlist team selected Flutter for its ability to deliver a fast, highly branded experience. According to Superlist co-founder and the head of design, when starting Superlist, they knew they wanted an amazing design, flawless user experience, and an app that felt consistent across devices and operating systems. It quickly became clear for them that Flutter was the right foundation for their tech stack. With that focus on amazing design that they had in mind, it was critical to have full control over every pixel on the screen. Doesn't matter if it is a static page or animation, their aim was to make the product delightful and engaging. And Flutter was the framework that allowed them such a granular control over screens and provided great out-of-the-box animations, as well as easy-to-use mechanism for creating custom ones. Now I quote, "Flutter enabled them to do things they would have never tried in any other platform, and helped them to create an app that felt familiar yet special. It was important for them to be cross-platform from the start. Today, they have a Mac desktop application released to beta, and they are actively building Windows, Android, and iOS support, all within the same Flutter codebase. Isn't that inspiring?" All right, I will now share another example, much simpler in terms of UI, but yet showing the productive developer experience. Flutter can be done on any desktop operating system. Here I have the development environment set up on my MacBook. In terms of IDE, you can use VS Code, Android Studio, IntelliJ IDEA, or even build Flutter applications from the console. Here you see my personal preference, Android Studio. Additionally, tools for native development need to be present on the machine. If you plan to develop for iOS and macOS, then you need Xcode installed. For Android development, you need Android SDK, etc. I have a real-life Flutter project open here. I recently gave a technical talk at Flutter Global Summit and used this application as an example of advanced networking layer implementation in Dart and Flutter. It downloads some data and presents it in a list. Here you see folders for all platforms: Android, iOS, Linux, macOS, web, and Windows. Inside of those, you will find native applications wrapping the Flutter code. And there is also lib, a folder where the Flutter code is written, as well as test, a folder where tests for it are. Here you see a main file open with just some example of a Dart language. You will find Dart very similar to many programming languages, and overall, it's easy to learn. Here I have a list of devices I can run this application on my machine. And I actually have it already running on multiple platforms. So here is the Android, and here is the iOS simulators running. You see, the applications look kind of the same, but yet slightly different. Check this out. On Android, we have a nice overscroll effect with ripple, which is typical for material design. And on iOS, we have bouncing feedback, which is typical for Cupertino style. Also, look at the up bar title. It's pinned to the left on the Android and centered on the iOS. So Flutter follows some of the typical operating system patterns out of the box. But it also gives you the granular control over all pixels on the screen, so you can customize the title to have the same position on all platforms. And there is also a macOS desktop version running. You can see when the application is in focus, there is even the native menu on top. The nice thing about developing desktop app is that you can easily check all sizes and all form factors of your applications in a single run. And I also have a web version running. Let me show something cool here. I'm going to change the main color application to purple. Now I click hot reload all devices. And voila, all the applications has immediately reacted to the change. And I didn't have to recompile and redeploy my application. And the state of the screen was preserved. The cool thing about Dart is that it supports both just-in-time and ahead-of-time compilations. So when developing, it is very fast, enabling hot reload. And when the release time comes, the applications are getting compiled, which ensures their stable work in production. Hopefully you've gotten a peek at what Flutter developer experience can be like. Now you might think, okay, Anna, I'm sold. How do I start? Well, the last year I also spoke about Flutter at Women Tech Network Global Conference and already shared a bunch of useful links, as well as additional information about Flutter, its architecture, principles, and also some case studies. So go check it out. Also, I suggest to check out the written workshop From Boring to Beautiful and the recorded video session from Google I/O where two Googlers take all the steps from this workshop and also comment on the content. Additionally, check out the official website. Happy fluttering!